Welcome to Pioneer's Knowledge Hub.
Have you ever taken a sip of seawater and immediately regretted it because of the overwhelming salty taste, yet river water doesn't have the same effect? Why is that? Welcome to the enigmatic world of water salinity. Today we're going to dive into the topic of why two bodies of water, both vital to our Earth's ecosystem, can taste so remarkably different. Consider the sea, vast and seemingly endless, filled with a cocktail of minerals making it notoriously salty. Then think about a river, winding its way through the landscape, its water fresh and clear. These two bodies of water, though they share the same fundamental molecules, offer us two distinct experiences when it comes to taste. This stark contrast raises an intriguing question. Why is seawater salty, while river water isn't? The answer to this mystery is not as simple as you might think. It involves understanding the process of weathering and the water cycle. Intriguing, isn't it? The answer to this mystery lies in the process of weathering and the water cycle. Let's delve into it. When we talk about weathering, we're referring to the process where rocks on the Earth's surface get broken down into smaller pieces. Now imagine the Earth as a giant jigsaw puzzle, made up of various types of rocks. Some of these rocks hold different salts, like sodium and chloride. When the rocks undergo weathering, these salts get released. There are two primary types of weathering, physical and chemical. Physical weathering involves the breaking down of rocks into smaller pieces by physical forces like temperature changes, water, wind, and even plant roots. Imagine a rock sitting out in the desert, heating up under the scorching sun during the day, and then cooling down rapidly at night. This cycle of heating and cooling causes the rock to crack and eventually break apart. On the other hand, chemical weathering involves the alteration or decomposition of rocks due to chemical reactions. Picture rainwater, slightly acidic due to carbon dioxide in the atmosphere, seeping into the rocks. This acidic water can dissolve some types of rocks, releasing the salts they contain. But how do these salts end up in the sea? Enter rivers, the Earth's natural delivery system. Rivers collect the salts released by weathering as they flow over the land. They then transport these salts, along with other sediments, to the oceans. Think of rivers like a network of highways, constantly moving. They pick up passengers, the salts, from various locations, the weathered rocks, and drop them off at a central hub, the ocean. Over millions of years, this process has led to the accumulation of salts in the oceans, contributing to their salinity. So, in essence, weathering acts like a giant salt shaker, sprinkling salts over the Earth's surface. The rivers then act as conveyor belts, carrying these salts to their final destination, the sea. So, weathering is one of the main reasons why our seas are salty, but how does the water cycle play into this? The water cycle, a continuous process that moves water around our planet, plays an essential role in the salinity of seawater. The water cycle is the Earth's great recycling system. It starts with the sun, which heats up the surface of the Earth, causing water to evaporate from oceans, lakes, and rivers into the atmosphere. This evaporation process is where the salt starts to play its part. When seawater evaporates, the water molecules turn into vapor, but the salt, being a solid, stays behind. This means that every time water evaporates from the sea, the salt concentration of the remaining water increases, making the seawater saltier over time. Now, you might be wondering, doesn't water also evaporate from rivers? Yes, it does. But here's the thing. Rivers are constantly being replenished with fresh water from rainfall and melting ice from mountains, which are both parts of the water cycle. This fresh water dilutes the salts in rivers, keeping their salinity relatively low. Moreover, rivers have a secret weapon, the land. As rivers flow towards the sea, they pass over rocks and soil, which absorb some of the salts, further reducing the river's salt concentration. So even though evaporation does leave salts behind in rivers, the combined effects of dilution and absorption keep the salt concentration of river water much lower than that of seawater. But let's go back to the sea for a moment. After evaporation, the water vapor in the atmosphere condenses to form clouds, and eventually falls back to the Earth as precipitation. Some of it falls over the sea, diluting the seawater a bit. But remember, the sea is vast. The amount of fresh water added by precipitation is small compared to the volume of the sea, so it doesn't significantly decrease the sea's overall saltiness. Interesting, right? The water cycle effectively increases the sea's salt concentration while keeping our rivers relatively fresh. You might wonder, if rivers keep carrying salts to the seas, wouldn't the seas become saltier over time? It's a valid question, and the answer lies in the concept of salt balance. Just like a well-maintained diet, the ocean has its own way of balancing its salt content. This balance is maintained through various processes. For instance, when seawater freezes to form sea ice, most of the salt is left behind, effectively reducing the overall salinity. Additionally, marine life plays a crucial role in this balance. Creatures in the sea, from the tiniest plankton to the largest whales, absorb salt in their bodies, and when they die and sink, they take that salt with them to the ocean floor. So even though rivers continuously transport salts to the seas, these mechanisms work in harmony to prevent the seas from becoming too salty. So while the sea does receive new salts from rivers, these processes ensure it doesn't become too salty. So, there we have it. We've demystified the salinity of the sea and the sweetness of river water. We've seen how the process of weathering plays a crucial role in this. Over time, rain and wind erode rocks, and the minerals, including salt, are carried away to rivers and eventually to the sea. We've also explored the incredible water cycle. The sun's heat causes evaporation, and seawater, leaving behind its salt, ascends to form clouds. This water eventually falls as rain, replenishing our rivers, sans the salt. Finally, we dove into the balance of salt in the sea. The ocean is like a great salt warehouse, storing it over millions of years, while various processes help maintain this balance. And that's why seawater is salty and river water is not. It's fascinating how nature maintains this delicate balance, isn't it? Yes, indeed, our planet is a marvel of natural engineering.
Please do like, share and subscribe to my channel. Thanks for watching.